we are going to learn calculus, right? Calculus is the mathematics of change. Like geometry is the mathematics of shapes and sizes. Algebra is the mathematics of relationship between quantities. Probability is the maths of chance. Now, algebra is the mathematics of change. This was developed by two mathematicians. One was a physicist as well as a mathematician. The other was a mathematician. The name of the first one was, we all know him. His name is Sir Isaac Newton. And the other one was Leibniz. Gottfried Leibniz. Now, where do we actually see this being done? Right, like if we have a GP series starting from 2, 4, 8, 16, 32, 64, if we plot it on a curve, we see that it varies like this. In case we have a series which starts like something like 5, 7, 9 and so on, this is an AP series that has a curve like this, intercept 5. Now here the rate of change of this is to this, we all know, is change of x. Say this is change of x, which we sometimes call del x by del y. It's constant. Sometimes it is written as rise versus run. This is constant. This we can just take 2 points, just like this was 1, this was 2, 0, sorry, this is 0, this is 1. So we can easily write this as 7 minus 5 by 1 minus 0, which is equal to 2. Now this is predictable in the sense that anywhere we go, however small we take this or however large we take this, the change of this y, of this function to x, which can be denoted by 1, 2, 3, 4, is always 2. But if we have some other functions, like we consider a case which starts off with 1, 4, 9, 16, 5 square is 25. So this is 1, 1, 0 for 0, 1 for 1, this is here, 2, 4, it goes steeper and steeper. Now the problem here is that the way this value, if we take 2 points on a line as we have just taken, we have taken 2 points on a line, this gradient or this slope does not change, but here this theta does not change. But here if we take different points, like if we take this point with this point, this slope, and again this point and this point, this slope is different. Now we just cannot find out how these are changing. Here comes the concepts of limits. Like, when does it occur that suppose there is a function like this and we have to calculate the tangent, the slope of the tangent. Now tangent is exactly 1 point, it's not 2 points. But in order to get the slope of a line, we need 2 points. So in case of a circle, what we do is, in case of a circle, suppose here is the tangent, we can make parallel lines. Now from here, if these are called seconds, in case the second becomes 0 as it tends to 0, as it tends to 0, we get how the circle changes. So suppose we have a kind of a graph something like this, and we write this as x and this distance as d and this distance, if this is what I write as y or function of x, this is the change of function of x or f of x plus h. This is x plus h or x plus d, sorry. So now we make this distance smaller and smaller so that this chord actually becomes a tangent. The moment it becomes a tangent, we can find the rate at which this point changes the value. So the first principle from here we can find out is limiting h tending to 0 function of x plus h minus function of x by x plus h minus x. That is the rise versus run of these two functions. This is what is often written as del y by del x or dy by dx. So this is it for the first class. We will discuss more later on.